Okay. Ow. All right. Now, talking about kind of our main part today, our main form of math. Yesterday we were discussing, the different sets of real numbers. I think that's what we got yesterday, right? We talked about naturals, wholes. So we talked about all that stuff yesterday. What point did I get to? Did I just talk about expressions?
Talk about pandas.
Pandas. Okay, so we ended there. Okay. So the goal today in your homework, we're on section P.1, just so you know.
You have homework?
We're talking about expressions. Yep, we are going to get homework today.
Wonderful.
Okay, it will be due on Thursday. It's ridiculously simple. And I'll explain. I'm going to go through examples of every type of homework problem you're going to get today. Okay, so we're talking about expressions, different types. Now obviously the title of the section is actually called algebraic expressions. That's the title of the section, but you get the idea there's like more than one type. Okay, so one of the main problems you're going to have is algebraic expressions. That's actually going to be like your first two problems. Okay, we talked about these yesterday. To do an algebraic expression, you have to use the order of operations. So it could be something like this. Maybe this is your problem that maybe this is like example number 2 out of the book, or the homework that you're going to have. And they're going to tell you off to the side that x is 3, y is a negative 2, and w is 5. And they're going to ask you to simplify or evaluate. Okay? I believe on this problem they say evaluate the following expression, because evaluate means to get it down to its single digit. Because you can plug in the x, y, and w into this problem up here, and then you just do your order of operations. Does that make sense what they're giving you? We're going to go through this problem just to make sure you know it and you're familiar with it, then we're going to get to the next types of problems. Okay, so x is 3, so I'm going to plug 3 in here. The y is a negative 2, so that's negative 2 times that, and then plus the 5. Okay, so in PEMDAS, the order of operations, what we talked about yesterday, you have to do parentheses first. So I need to go inside this parenthesis and do any parentheses that are in here. Well, I know this looks like parentheses, it's actually just multiplying. It's not like distributing or anything like that. So inside the parentheses, finish this math off. 3 times a negative 2. Negative 6. We're going to add 5 to it. So, again, I need to finish the parenthesis before I can move on. So adding negative 6 and 5, negative 1. Okay, so now that I'm technically done with the parentheses, right? I've done all the math on the inside, I got it down to one number. Now, because again, what I'm doing is I'm doing PEMDAS, right? I'm doing parentheses first, check, those are all done. There's no exponents. Can I multiply and divide? Yes, I can multiply. 4 and a negative 1. Negative 4. So those are all done. Now I want to add and subtract last. So that's negative 1. There's your answer. Move on to the next one. Do I expect to see every single form of that work? Probably not. Maybe 1 or 2 steps. Okay. I expect to probably see maybe you got down to this point, maybe you got down to there. I have no idea how you want to do that. If it takes you like multiple steps in your head to think through it, you probably should be writing that down. I don't want to just see this written down on your paper and then that. Like there's something you have to do in between. You probably have to think of these few steps. Do we feel comfortable with the first 2 or 3 problems you're going to have?
Yeah.
I think you only have 3 of those, I'm not joking. But do we feel better about that? Okay. Yes, you can use calculators. You guys know the drill. I have calculators in the back. It looks like a lot of you already borrowed them. That's great. Okay. Just make sure to get them back. I had all 10 when you walked in. All right. We're good with the first type?
Yeah.
Second type of problem. Now, this is the stuff that we were talking about yesterday, or at least I was alluding to. You're getting to sets. What a set is, it is a list of numbers, right? It's a list of answers, possibilities. It's just a list. It's in a particular order. That's what a set is. It could be a set, an answer for a certain problem. It could be, whatever. There's different forms of these. There's different types of sets. There's roster method. There's set builder. There's interval form. So there's different forms of a set. I I think the one that you're probably used to, that you've probably seen a lot in Algebra 2 and Geometry days, is probably roster method. What a roster method is, it's a list of numbers. So maybe they do something like this. Like curly brace, 1, 2, 3, 4. How many people have seen lists like that? Written curly braces? Okay, that's probably the one that you're probably most used to seeing. That's a set. They typically go least to greatest. If there's decimals in there, they might put a dot, dot, dot instead. Like 1, dot, 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 4. That literally could mean every number in there. It could just mean the whole number. So the problem with sets is they typically will list off all the ones that they want. If they want to use decimals, they'll probably use one of the other forms, because it's just easier seeing the decimals in the other forms than this top one. Top one is usually reserved for like natural numbers, like 1, 2, 3, negative numbers like integers and whatnot. Now, what we're going to do with it is we're going to look at how to compare sets together. So why we do this is if you're looking at two different math problems, and you know you have different answers that can come out of these problems, and maybe they're looking for what is the common answers they both have, like a Venn diagram, right? A Venn diagram from English class, you're looking at a set of answers over here, a set of answers over here, and you're looking for those similarities or differences. I don't know what your Venn diagram is going to represent for you. So the idea is that that's one type of set. That's called an intersection. It's where they overlap. Intersection is the overlap. A union is combining. A union is everything, right? Like a union at work. All workers form up to be one solid mass, right? We see the difference between the two words. Now, why this is important is because later in the section, later in the book, we're going to be getting to problems that have multiple answers for a problem. Where, like, you could have a lot of decimals, a lot of fractions that work on this particular problem because it's spitting out a range of answers. And we're looking for where do they intersect, because maybe there's two different lines going. Where do they cross? Maybe two circles are crossing. Where do they intersect? So there could be multiple answers, like this. So they're going to show these different ways. So this is one of the examples I'd like you to write down. Okay, does everyone see that little N in the middle of them? Okay, I have two different sets, you agree? They're both in the roster method. Does everyone see the little N in between the two sets? That N stands for intersection.
Colin Mary, please come to the office. Colin Mary.
So this stands for intersections. So what that means is an intersection, according to a Venn diagram, is where there's overlap. So in the first problem, in the green problem, if you're colorblind, sorry, but in this, there's a few answers, there's 4 different numbers. Or there's 4 different numbers in that problem. Is there any overlap between the two sets?
3, 4.
3 and 4, that's your answer. All this whole thing, when I wrote that whole thing down, this is the answer. 3 down the 4. That's the answer I'm looking for. That's the common answer between the two sets. Does that make sense, what they're looking for? Now, this will make way more sense later when we start actually like using problems and this is how we're going to answer the questions. Because maybe you're looking at intersections of two circles and you have to list the common answers between the two circles.
So this is on our homework?
Yeah.
Okay.
Yeah. So I think that's easy. They're going to automatically give you the two sets and they're going to ask what are the intersection numbers.
Oh,
I love
it's gonna be exactly.
It's going to be exactly like that. In fact, that might be number 50. All right.
That's okay.
Okay.
I love that
So-
for myself.
We can handle that.
Okay, questions on that? Okay, now let's do the other one. Because obviously I said intersection. The other one could be a union. Okay, so a union.
Is this all for the roster method?
Yes. This is a union. It's a U, literally for union. Right? So in a union, what are all the different numbers you see? You don't need to say the repeating numbers multiple times, just what are the different numbers in both lists that you can definitely see. So list them out. What do we got?
We're all 5, 6.
Yeah. 1, 2,
Good job, Ethan.
3, 4, 5, and 6. And notice I even put the 3 and 4 in there, but I didn't write them multiple times. I'm listing every number from both sets in order, least to greatest. Does that make sense for a union? Every number, including the ones that overlapped, it's everything, but I just don't have to put them like multiple times. I don't need to write 1, 2, 3, 3, 4, 4, 5, 6. I don't need to do that.
Just list those numbers.
Just list every number that you see in order. Be careful because some of the lists, like they might leave a number out here and there. So you got to be real careful like what numbers they actually have. But you have to put them in least to greatest. Do we feel comfortable with a union? Union's every number you can see. So you literally combine everything into one group. Now, here's the question. So I'm going to give you an example now. Because now I'll give you both types. So here's your example I want to see. 3, 5, 7, 9. 2, 4, 6.
Ain't no thing.
Why?
Because they don't have the same numbers in both.
Okay, good. You recognize this was an intersection, right? As an N for intersection. So I'm looking for what do they overlap? The Venn diagram. Where do they overlap? Nowhere, right? This one had it had basically odd numbers. This one had kind of a mix of odd and evens, but there was no numbers that overlapped, right? So, since it was talking about an intersection, I'm looking for do they overlap? There was no overlap, right? So your answer is that. That is not 0. Okay? It has a slash through it. It's actually called the null set or empty set. They literally have no commonalities. They didn't intersect. That could happen. You could have 2 circles on a graph that never actually cross. Or like a hyperbola. A hyperbola looks like a U shape. And a line. Maybe they don't intersect because maybe they're in different spots. So there's literally no answer where they would be. Okay, do we feel comfortable with that? Now, if it was a union, then you'd list all the numbers out. 1, 2, 3, 4, 5, 6, 7, 9. But an intersection, where do they overlap? Okay, do we feel comfortable with all the different types of problems that we have? Yeah. That's literally all your homework. That's it. Like I can't think of anything else that would be you probably need to know. So there you go. There's your homework.
Have you done with our homework yet?
What?
Have you done it yet?
No, I'm going to do it as you guys work right now. I literally got a piece of paper and do it the same thing. Okay.
Are we probably going to finish it?
If you don't, you're doing something wrong. So,
I don't know,
it's due
man.
Thursday. I'm giving you a couple days. I don't think it will take you more than 10 minutes. Honestly, I'm pretty sure my son could probably do this. So.
You've never met me that.
He just started getting rid of
You've obviously forgotten how skilled I am at that.
it. No, I have full faith in your son.
Matt, you want to